and environmental engineering from University of Clarke, United Kingdom. He currently serves as a faculty member and researcher at Atlantic Technological University, and he also the founder of World Resource Management and Soft Computing Research Laboratory in Sri Lanka. Over his career, he has held academic and research positions in several countries, including Ireland, Japan, United Kingdom, New Zealand, Fiji, Australia, and Sri Lanka. Professor Ratnayake is an internationally recognized researcher and ranked among top 2% of the researchers worldwide. He is a high-impact scholar with the H index of 38 and I-10 index of 49 in Google Scholar. He has authored over 120 peer-reviewed journals and also written books, chapters, and delivered numerous conference presentations globally. His research interests includes water resource management, hydrological and hydraulic modeling, climate variability and change, and multi-objective optimization, soft computing techniques, including machine learning and AI applications in environmental engineering. In addition to his research achievements, Professor Ratnayake has achieved numerous prestigious awards, including Sri Lanka Presidential Awards for top scientific publication, multiple University Excellent Research Awards, and Best Paper Awards at international conferences. He has also served as an editor for several international journals. With this remarkable experience and expertise, I'm sure we will be having an engaging and insightful session today. So without any further delay, I would like to invite Professor Upaka to take over the session.
Okay, thank you so much. It was not a brief introduction, actually. It was the whole CV, which I never expected, but you can call me Upaka. That's totally fine with me. So we don't really use any titles for the names. So just Upaka is totally fine with me. So before I head into the talk, I wanted to emphasize a couple of things about the university itself. So I'm representing Atlantic Technological University, Sligo, Ireland. So it's a relatively new university. You probably haven't heard that in Ireland. You probably have heard Trinity College, UCD, University of Galway, like that. But Atlantic Technological University was established in 2022. Well, it was like combining several institutions of technologies together. It is to cater the regional development of the country, and northwest of the island has a Atlantic Technological University, where it serves for 29,000 students at the moment. So if if you look at the history of the institutions, these institutions were like 60 to 70 years old, and they combined together to perform to the localized area in a different name. That's what has happened. So Now, right in front of my university, my campus, we have this guy. That's a salmon. Not the jack mackerel. That's a salmon. Salmon has a float tail to the island. They call it it's the wisdom or the truth or the knowledge. So there is a big kind of like a fairy tale in it, but that represents the knowledge. So the university seeks the knowledge, new knowledge. So that's why they had this salmon for almost 50 years now. Yeah, almost 50 years. Okay, now what I was asked to deliver today is to get a problem into research world. Now, I was yesterday talking to another place like Gap HQ. I was talking about the Sri Lanka's resilience and research impact to the Sri Lanka's to the development. So I'll take a couple of examples of that talk as well when we move on. Okay. Oops. No. Can you just take it if it is moving? Pointer is working, but okay, I'll go, Daiji. All right. Before we go into any presentation stuff, I would like to take a couple of case studies. Now, when I was working in Sri Lanka for a particular institution, we had this implant training in second years and third years. So the students used to go to the implant training, and we used to go and visit them. Now, student didn't like me because I used to go without telling them that I'm coming. So they didn't like actually because I'd probably be the only one to inspect them without telling. But the good thing was I think I still can manage the both languages in Sri Lanka. So usually I was asked to take the island-wide route. So I'm taking it probably from say Aturgiriya, then Chilav, Putlam, Mana, Talaimana, then you come back again Punarin, all the way off Jaffna and Mulatiu, coming again back to up to Panama and come all the way. So it takes usually 6 to 7 days to cover everything. And I like that because you can learn loads of things. I usually go for the inspection. I voluntarily go for the inspection of the students. Now, when I was traveling, I think this was in 2018, I believe. I found this interesting case, Chilla Bridge, along the way to Putlam. And those who are from civil engineering, they might probably know what's happening here. So pile caps are exposed. That means you have a severe erosion of the river. And you can see again from these pictures. And next to that, you have a railway bridge where you have again many issues, and you never know what is going to happen in another 10 years time because of the erosion. Now, this has a long history because of the sand mining, illegal sand mining and so on in Dadruya, but yet we had to provide some solutions because Dadruya has 5 interesting bridges where we have to give some structural solutions. So I was thinking that, okay, I'm a civil engineer myself, even though I haven't really touched into the structural engineering stuff. And can I think of a solution for this? Can I look into a solution for this particular case? Right away, I call one of my own batchmates who is working in the relevant authorities. I'm not kind of telling you the names or the authority names because to keep everything confidential. So I call my friend and I ask, can we do a full hydraulic model to this particular river basin and understand the scenarios? He said, "Machan data nanne." Even though we have data, we can't get it freely. So that was the first challenge which I faced. No data availability. Then zero support from the relevant authorities. Even though I talked to the directors of several relevant organizations, and they said that yes, there is a problem, and we have difficulties of getting probably funds or whatever the things. Then limited funding for the work which I taught. In fact, it was self-funded. So I still use my own pocket to fund some research work. So it was self-funded. And we had the software issues as well. Because if you're using GIS, you probably know that we can't really use a cracked version of GIS and say that write it in a paper. They will come back to you and simply ask you to think, see, you guys don't have the license for this particular software in your university or in your institution, and you have to remove that paper. So that has happened in the world. So we had various issues. Like, these are challenges which I face in finding a solution for this. I could easily say, at least for this one, why should I waste my own money to get some solution when these are not important, when they don't want to really engage in the work? But this is the outcome. This is the outcome of the work which we have carried. So we were able to get the meandering pattern analysis to the river itself. And we were able to publish that work. And I can't really remember whether it is a Q1 or Q2 journal paper. So land. So we were able to publish that paper. So we got several help. Professor Nitin is from University of Victoria, Melbourne. He is a long time friend of mine. So he said he is happy to help in some analysis. Then we had Dileepa Hettiarachchi. He's from irrigation department, senior engineer to Putlam area at that time. So he helped with various images and so on. And again, I have Amila Abenayaka, another batchmates of mine from Peradeniya. So he helped with the analysis and so on. Now, that is the final fruit from the work. I still want to tell. Oops. Okay. So I'm highlighting a couple of them here. So see this Vindhya Basnaik. Look at now. She's a PhD candidate at University of Twente, Netherlands. And then we have Jayanga Samarasinghe. Vindhya was from University of Peradeniya. Probably you can remember her. She's one of the very best students from University of Peradeniya. So she has completed almost 8 to 9 research work with me and has all the papers published. Then we have Jayanga Samarasinghe, an interesting character. He's now a PhD candidate at University of Texas, United States. He couldn't enter to the Sri Lankan state university systems. Then he chose a SLTC. I'm not promoting, but I'm telling you the truth. So we have very good guys. So he was a graduate from SLTC Sri Lanka. Then he worked with me for various research projects, and I think he's now having an H index of 10. So he's into his PhD. Then we have Muru Gunatilaka. You probably heard this guy Muru is the son of Mr. Gras Gunatilaka. He is the Director General for he was the Director General for CECB. So he couldn't even enter the state universities in Sri Lanka. He entered Saitam, and now he is a PhD candidate. He's finishing his PhD this December. He's in Oulu and so on. Then my friend Dilepa, because of this work, he's a PhD candidate in University of Stavanger, Norway. Now, all what I wanted to tell you, I'll go back. If we thought to stop the work just because of these challenges, they might not be the latter people. They might not be there as researchers in their careers. So we took the challenge. We took the challenge to when you see the challenges, you always try to motivate you and make an opportunity. So that's what we have done. Now, if you ask from me how we have done without data and so on, we use satellites, Landsats, 30-meter resolution Landsats. We use the Landsats, and we have even found the coordinates of the meandering behavior of the river itself. So all what we wanted to tell in future, these are the meandering patterns in the Ratnayake. So we have found all of these information, and the paper was open access publication, and we have sent it to the relevant authorities. Unfortunately, nothing has happened since then. And after a couple of months, the same institution where I worked received a project from the authorities saying that we have a problem in that area. We have some grants. Would you like to do it? Because we have already completed it free of charge and we have shared it. It was not used. Yesterday, when I was talking to the GAP HQ, people came to me and a guy from, I think he's from University of Peradeniya, he said that, sir, I have done this similar kind of research for my bachelor's studies, one for the Daduroya Bridge. So still the scenario is same. Now that was in, when was it? I think that was in, I can't really recall, 2018 or 2019. Okay, that's one case study which I wanted to showcase you. Now there is a reason for me to showcase this stuff. I'm just picking a couple of them. Then, yeah, another case study which I wanted to talk with you. So, I'm working with several people in Uzbekistan. So researchers, Panchali is working with them as well. She worked for one journal paper, and so when we were having some fun time, online fun time, we heard that Uzbekistan is facing a severe issue. Now, Uzbekistan as a country is receiving, say, 100 to 200 millimeters of rainfall. Okay, 100 to 200 millimeters of rainfall for the whole year. Now, if you look at Sri Lanka itself, you have a Hambantota area and Mana area, which we call, they are the driest areas in Sri Lanka, or arid areas, which still receives 700 to 800 millimeters of rainfall. Now you can imagine the situation in Uzbekistan where they don't have the option to have any sea. It's a dry place. But imagine the country is an agricultural country. They're getting 100 to 200 millimeters rainfall per year, and still the country is an agricultural country. Now, what they had the problem was, I'm sure you know about IPCC and so on. IPCC ranked Sri Lanka as the third most affected country from the climate change in their sixth report. Just like that, Uzbekistan is severely affected by the changing climate. So they wanted to understand what would be the impact of atmospheric changes into the soil layers. In fact, it is not the surface of the soil, underneath the soil layer. Why on earth such a thing to be investigated? They realized that the seed germination is very important. The first 10 centimeters, the initial root zone, is very important for seed germination, and then that will give the results in their harvest. If something happens in the seed germination time, they won't get the expected harvest, and they can't export the things, because Uzbekistan is very famous for their fruits like plums, apples, grapes, and so on. So they wanted to look at the soil profile temperature changes, and they had some measurements, and but they wanted to look at the forecasting model. What is going to happen after several years' time? Imagine the importance. We haven't even thought those things in Sri Lanka. Unfortunately, even though we are people who eat rice for 3 meals, we are going to have a severe problem in future because of the changing climate, and we are daily seeing the population is increased, but again the harvest is getting down and down because of the adverse climate. So they wanted to look at this particular problem. Okay, now I'm showcasing the outcome. So the outcome was published in Nature. You probably heard about Nature Scientific Reports. Now to publish Nature Scientific Reports, you probably need 3,000 euros, as the publication charges 1.2 million and so on. So have we had the money to publish that one? No. Now you may ask, how did we publish this one? Because of the work itself, they have provided us the full waiver. So it's free of charge publication. So this guy, Lakindu is from mechatronics engineering, and he came to look into the AI in agricultural technology knowledge. And we have several people from Russia and Uzbekistan. Then we have Dr. Namal. He's from now he's working to JAMSTEC in Japan, Japanese Meteorological Research Center, which is the #1 research center in Japan. He's a senior researcher. He was my PhD student. Now he's a senior researcher in Japan. Then we have several other people. Komali is the co-director for United Nations Spider Program. She's from University of Central Lancashire, UK. So we get together and we work for this particular problem. And Hoshino is their professor. Hoshino is again a professor of computer science. Okay. Now this was the model which we have created. So if we can get the atmospheric data, for example, temperature, relative humidity, this and that, and so on, and you can see that we don't really have precipitation here. It's just because you can't get any precipitation in Uzbekistan. So we wanted to predict the soil surface temperature. Then based on that, we forecasted the soil temperature at 10 centimeters level. So that was the problem which we have solved, and it was published, and they're using this paper into the policy development of the country. A bit of mathematics of the problem and so on. So we were able to forecast even the peaks and so on. You can see we were able to forecast peaks of the soil temperature levels with the measured value. It's a very fine match. We used state-of-the-art artificial intelligence to do this, and I can say that it was a successful story. So why I have taken these two case studies, I just wanted to showcase you that without funding, you can do wonders. Okay, I'm funded. I have funding, like I have collectively obtained 1.5 million euro, probably 500 million rupees in funding now. But again, without funding, You haven't had a single penny to use for these works, couple of works, but still you can do wonders. And the first one was disseminated regarding the Dadroya. It is not used. Okay, we have done our part, but it is not used by the relevant authorities or the policymakers. Second one was we have done our part, again disseminated, and they are using it now. The country is using now. Okay, those two case studies. Then I would like to move into how to formulate an engineering problem. I took this word engineering. Now we think that engineering is now when you are in medical professional, when you are in social science profession, you think engineering is not your piece of cake. But I would like to tell everything is an engineering problem. I'll take another example. Anyone from civil engineering background? Now, by any chance, do you know the meaning of civil engineering? You may think that it's just construction of buildings, this and that and so on, isn't it? But civil engineering is not that. Civil engineering was formulated in Second World War time, when there was the World War time. You know, people used to do loads of technical and technological things to the war. That's called military engineering. What's the opposite of the military? Civil. So whatever not comes under military engineering was put into the civil engineering. So that's what we call civil engineering. Civil engineering is everything around the world. That's why I call it's everything is under engineering problem. You can formulate everything in this world using mathematics, even music, even our blood circulation. You can formulate everything in using mathematics. So if we look into the history, the famous musician Beethoven, when he composed his last one, that's symphony, he couldn't hear, he couldn't even say, but he still composed that just because of his knowledge of mathematics and so on. No, so it's not popularized in the world, but you can formulate. So I wanted to tell it's an engineering problem which you are going to solve. Okay. First, I'm not an expert, even though the introduction was long. I'm not an expert in this, and so I'm just a learner, still a learner. So I'm not an expert, and this is not the universal method. This is not the universal method. So my method would not be suitable for someone else. But still, I am using this method, and for almost 20 years, and it was working, and it is working. So that's why I say I'm not an expert. So you can find thousands of alternative ways to do the things. So this method worked for us. That's why we were able to, our group was able to publish more than 230 index journal papers now. So we have published more than 230 index journal papers. So I'm going to share my experience about that today with you. So I took a couple of examples, showcase you, to motivate you, where you can do wonders without things. If you have the attitude, you can do these wonders. Okay, we can integrate two types of, or cluster into research into two major types. One is for a postgraduate qualification. You obviously, when you are into the postgraduate qualification, you have to do a research problem. You have to solve a research problem, and you probably have to do a dissertation or a thesis based on the qualification. So you have to do that, and it is going to be an individual effort. So when you are working for a postgraduate degree, your research is more or less your own baby. You have to take care of the baby. So your supervisor will be there, or your advisors will be there, but they will be guiding you. But it's your own responsibility to come up with the research project. So you have to find the solution by yourself. When you are starting your research, you probably know not 0, maybe 1% of the things. You may think that your supervisor knows 100% of the research work, But when you are about to complete your higher degree, you'll notice that you know much better than your supervisor because it's your own work. So that's basically for the postgraduate qualification, which we are seeking. We need to seek. I'm again taking the example. So you can do the research for a PhD. By any chance, if someone knows the meaning of PhD, yes, it's Doctor of Philosophy. Do you know the real meaning of PhD? Now, when you want to drive a car, you need a license. Just like that, when you want to do your own research without any advisor, you need a license. That's your PhD. Your PhD is the license for your research work. And in Sweden, if you know the story, Sweden and some other Scandinavian countries, they give license date before the PhD. That's the license for the PhDs. So when you have the PhD, you should be able to do your own research work without expecting someone else to guide you. We can ask the same question from ourselves. We have so many PhD holders in the country, but are we really doing that? Okay, the second one is, without taking time, for a consultancy or an index journal paper, you can still do research for consultancy. It's like commercializing, which I talked with these at Tarindu and so on, for commercializing the project, consultancy. It's a research project again. Now, I'm taking another example now. You probably heard about the Donald Trump's action against another country. He took out his bat out. That means the B2. So you call it's a bat because no one knew about the technology of this aircraft, military aircraft. And it simply hit. And I think the annual maintenance for one B2 is 300 USD millions. Just the maintenance, 300 million USD. So the production would have cost more than billions of USD. So they have number of B2s in the country. Was it just brought from aliens? I mean the B2? There was a project like this, a research project, which come to the truth. So whatever you see in this world, it is from research work. Someone has done research work to develop things. You take your mobile phone, if you go to 1996, 1995, you had this, you call Gadol Bagu. And the commercial term was Celltel. It was a Motorola phone. You say you can hit into the mango tree and so on. Now then you had in 2005, 2006, you had smaller phones. You really like to have that in your pocket, small compared to that guy. Now you are looking for the bigger ones with bigger screens, and you can do wonders from this one. You can control computers, you can control servers, you can do remote controlling and so on. So when I was doing my PhD, that was in 2000, I completed my PhD in 2012. I was using my mobile phone to, even at 2 a.m. in the morning, to remote control my computer in the university to give analysis. So that was 2012. Now you can do very, very high scenarios. If you are a civil engineer, you don't need a measuring tape now. You just take your phone and scan it. You'll get the exact dimensions. You don't need a level. You can keep it and you can get the level. So these are not just random outcomes. They are from consultancies. So some people have thought about this. Like sometimes some crazy people thought about these things and they put that crazy things into the words and implemented it. Now, who on earth thought about WhatsApp to be one of the biggest or the billionaires in the world. We use Skype. We used Skype back in 2006, 2007 to communicate. Now the company has been shut down because they don't have a market now. Then we use Viber. We're no longer using Viber. It's a very heavy software for the computer and it's very bulky. It's slow, so we don't like it. And we use WhatsApp heavily just because of the easiness. Now this again was from a research idea from someone. So they were able to sort it. So research can be for a consultancy. Then sometimes just for an index journal paper. So you don't need any consultancy and you just do it because you like it. You want to do it. Just like the Ratnayake case, we did it. It was never used. But I'm still happy. Why? I got another paper under my supervision. And that probably has helped me to get some promotions, whatever the things, some perks to my pocket. I like it. But again, the authors, you saw the authors, 4 of them are now doing PhDs and a couple of them are almost completed. So it's just for an index journal paper. So now the most important thing is when it comes to the consultancy or index journal paper, it is going to be a team effort. It's not going to be an individual effort. Why I am saying that? Most of the consultancy problems are no longer in a single area. It's well diversified now. It's multi and interdisciplinary. So you are crossing boundaries from engineering to medical to social science, this and that. So you need experts. I'm not an expert in medical sciences, but we have done various journal papers, research work in medical sciences, because we have experts in that area. So it's a team effort. Now, how do we formulate such things? So which I'm going to target today is this one, because I know you are not that much interested about the postgraduate qualification. Some of you have, individually interested, but I'm giving the guidance for this one. Okay. Now, as engineers, those who are engineers, you probably know, we like assumptions. We always like assumptions. So just like that, assuming we have a particular problem to develop, just like the Ratnayake problem, I'm sure when you go from here to your home in the evening, you probably meet various people. And also you probably see various scenarios in the world. You can bring them as research problems. That's what has done. That's what has done in the world. So suppose you know the problem. Suppose you know a simple problem that you want to solve. And that means we know the gap. Gap is known, so you need to fulfill that gap. That is what we are trying to do. You know the problem, that's the gap. For example, if you notice, you have heavy traffic in front of the Moratuwa University and Arthur C. Clarke Center. That's a problem. You want to solve that. So that's your gap. So you have to fulfill that gap in order to find a solution. Now, finding research gap is another detailed topic to discuss. Suppose we know the research gap. Then, first and the most important, you need to read the problem. Second, again read the problem and understand it. Third, again read the problem, understand it, but with physical meaning. What do we mean by physical meaning? Now I'm taking you back to probably to your advanced level examination. Now, if you ask yourself now, If you are given a chance to sit for the same examination paper, would you do better compared to those days? Now, I'm again taking one of the problems or the problems which you probably had, those who have done combined maths or pure maths. You probably know this. Probability, combination and probability. You had a problem from combination and probability in your maths examination. It's an easy one, isn't it? Probability is very easy. You just have combination NCR, NPR, and so on. Just have plugged in. But if you look at the stats, that's the least attempt. That's one of the least attempt problems in advanced level. Why? It's a very junk question where you have to read and understand, then apply it. So you are not doing it. You are not reading it well. So in order to understand probability, you have to read the question probably 3 times, 4 times, 5 times. Then only you will understand these sentences are for this. So we are, as a nation, we are very lacking. We lack with this technique. We are very good at work, but again, we don't understand the thing. We don't read the thing. We don't read and understand it. Then we don't put that into physical meaning. So we probably are very good mathematicians. We can solve double integration, triple integration, but we don't know what does it mean by triple integration. Or we don't know how to tell, what is the physical meaning of triple integration to the generic public. That's the layman's language where we are missing. We should be able to understand the things, and we should be able to communicate to the generic public. Now, many people were telling in Sri Lanka that the politicians are the corrupted peoples. Okay, forget about that. I'm not into politics, but it's our own responsibility as well. When you go into the projects, you are, I'm just taking civil engineers or engineers into the table. So you are in the board. You should be speaking. You should be spoken regarding the matters, and you should be able to tell this and that and so on. So I don't think any of the politicians in the world, not in Sri Lanka but also in the world, understand about the green traffic lights, green time. If you want to tell the slope, soil analysis, and no one understands those things. These are technical things where we are excelled. But you should be able to communicate that to the generic public. So that's what we are missing. That's a communication mistake which we are having. So once we know that, go to the next step. So reverse the third. What do we mean by reverse the third? So you have a physical scenario now. Okay, you have a physical scenario and you are trying to understand it. Then with your engineering sense, engineering means your technological background. So when you have a physical problem, you try to put your skills into that and understand it. See, it's the reverse of this. Because you are not given problems in this world. You have to seek for them. If you are a researcher, you are seeking for the problems. Now, if you look into some other countries, researchers are the people who are putting problems to the governments or the authorities. We have a problem like this. Shall we solve this one? It's a business model. Whether we like it or not, it's a business model. So it's vice versa. You solve the problem and you get some money and you recycle that money for new project. At the same time, you pay the salaries or you pay some perks to the researchers, and again you get some good indices and you climb up the ladder. We have to have that continuous process in achieving this funny word, sustainability. Time to time we have different catchy words. Sustainability. In 2014 or 2015, we had Millennium Development Goals. There were several, I can't really remember the number. We had Millennium Development Goals and we thought that by 2015 we were achieving that. Never achieved. Then we developed United Nations Sustainable Development Goals and we are hoping to achieve them. So we are linking our research into the sustainable development goals. Now, what I'm going to tell you now is the bitter truth. Research is a business model. Now, as from you, we had COVID-19. It was affecting all over the world. And whether we like it or not, we got a kind of a vaccine. Okay, it's not a single vaccine, vaccine within 3 years. And we sorted it out. Okay, there were some issues in that because we haven't really done clinical trials. I mean, the expected number of clinical trials, we probably haven't gone through the Helsinki agreement of medical things and so on. But yet, we got a solution. We are happy that we don't wear masks now and we are not isolated. So it's just within 3 years, we sorted the problem. Now, I'm taking the same example to the South Africa, or not really South Africa, the whole African region. You have Ebola for how many years? Do we have a solution? No. Why? Is it a bit difficult to find than coronavirus? I don't think so. No one is interested. That's a real case. No one is interested. Why? If you get a vaccine or if you get a treatment to the Ebola, you don't have a market. That's a simple idea. You don't have a market. Instead, you have a market in the coronavirus or COVID-19. So you sell the things. That's a business model. Now look at HIV. You have a vaccine or you have a cure now. Why? Because you have a market. But if you are trying to sell that into very poor country where they don't have money to buy, no one is expected to buy that one. So you don't have a market. So you are not doing enough research to find a good solution to Ebola. That's the reality. That's the bitter truth. So business model is always there with the research. So in order to fly with that, we need to understand the physical scenario well with physical, engineering sense. So you are trying to get a solution now. So when you see a problem, first you have to read it and understand it. Yet again, you need to obtain background information, a lot of background information. When you try to formulate or bringing a problem into the research table, you need to read a lot. Read the newspapers. If you ask anything from me regarding Sri Lanka, even though I was, when I was in Ireland, I know everything because I read newspapers every day. And sometimes my friends are asking, you are in Ireland, why you are reading Sri Lankan newspapers? I captured number of projects just because of these newspapers. I'll tell you one example. We did some analysis to one of the growing problems in Sri Lanka, Nilwala salinity barrier. We analyzed that as well. So we have published journal papers on Nilwala river. So it's just because I read the news and I understood that we have to do something. So newspapers are, I know most of them are fake, but you can understand a bit about the problem from a different eye. Why? We always, when we are scientists, when we are researchers, we always try to think about a problem in some different level, which probably is not the best. So as I told you, we need to understand the problems from the base of the generic public because they are our stakeholders. Whether we like it or not, the generic public is our stakeholders, number one stakeholder. So you can capture loads of information from a newspapers. We analyze Umaoya project, very controversial one. Without going into the depth, I would tell you that we used newspapers to capture most of the details. Then we visited the place and we again did some analysis. So like that, you can listen to the news, even though you felt they are like not relevant. Listen to that. So it's very important to understand the problems which we are having. Now, for example, if you look at the stats of the country, the youth 18 to 35 years old, do we have a problem? Yes. Employment, the income, they are not satisfied. That's why they are leaving the country. You can argue that. But again, is that the only problem which we are having? We have a gender misbalance in 18 to 35. So we have more females in the country than males. It's about 4%. We are not finding solution for that as well, because it's going to be a social crisis. So so you can get loads of information. See, I'm an engineer myself. I read these things so that I know. Then I think Sri Lankan health situation, health industry was ranked top 46 of the world, which is really good. We are about the other countries and so on. Okay, then observe the environment. Now this is probably we don't have this issue with the people who are here, but if you look into the youth these days, even though they are in a bus, that's what they are doing. They are in the mobile phone. They don't understand what is happening around. So we have to look into or observe the environment. You can learn thousands of things when you are traveling from one place to another place in a public transportation. The problems what we have. So those are the basic research problems. Then talk with peers, very important. Again, we need some third view about the problem, because we have only two eyes. Someone else would be looking at in a different angle. Generic public, one of the most important thing. Talk with them and understand it. Okay, then we have to justify the importance. If you don't justify the importance, whether you have a problem or not, whether you have a wonderful solution, no one would buy you. If you can't justify the importance of that problem. Remember the one that which I told, Ebola versus COVID-19 or Ebola versus HIV. So you have to showcase the importance. Someone has to fund you, to do a massive scale research project. So you have to showcase the importance and justify. Now you need to tell who is affected and how. For example, farmers, municipalities, industries, and so on. Now I'll take another example of this. So I think I bought 1 kilogram of red kakulu. I used to eat red kakulu because I'm from Badulla. So, in Jaffna, Badulla, and Matara, those three areas, we used to eat red kakulu, ratu kakulu, as the rice. So it was like 226 rupees for 1 kilogram, I think, recently, which I can't really remember the exact value, but it was around 220. Now, I visited Vietnam last year, December, for a conference. And I'm fond of Japanese rice. So I found Japanese rice was sold in one of the small supermarkets in Vietnam. So I wanted to buy a Japanese rice. So I bought the same Japanese rice from Vietnam, 2 kilograms, just the same price of 1 kilogram of ratu kakulu here. Now, Japanese rice is not from Vietnam, it's from Japan. Taxed, brought it to Vietnam, again taxed, get a profit of that, and you still sell it to me. It's much cheaper or less expensive than 1 kilogram of ratu kakulu. Are we missing something? Yes, we are missing something. We are a country, as I again told you, we are a country, we need rice for most of the time for 3 meals. If you go to the villages, they don't like anything else. If you ask the same story from my mom, she needs that. But again, we are increasing population, almost touching 22 to 23 million. We are reducing the landscape for paddy, and the youth is not so interested in farming. We have aging farmers. Have we found the solution? Unfortunately, no. Loads of scope in that area for agriculture and so on. Yep. So we need to find affected and how to give you the importance. Then economic, social, and environmental cost. What are the economic, social, environmental costs involved? Are these sticking you? Economic, social, and environmental. These are the three pillars of sustainability. So in a project, you have to achieve these three. It's not just economic that we are looking at. It's not just environmental that we are looking at, but also we have to look at the social issues as well. So when you solve all three, then you call you're solving or you're achieving or reaching the sustainability. Now I'll take another example where I have observed when I was taking my students when I was in Sri Lanka to run the area. Now if you go to the Minipe Anicut, you have two channels. The left bank channel is there. It was long time constructed one instead of the older Mahavali River. Then you have the right bank canal that is called the New Yoda Ala, Nava Yoda Ala, which is a wonderful creation by the civil engineers. Trapezoidal channel which takes water from Minipe Anicut to Loggaloya to Heppoloya likewise. So you take the water. And you probably heard about the accident recently happened as well in that area. So it's a massive construction. Now we are happy. We can take that excess water to the downstream areas and we can do agriculture. But we miss something. If you ask from the public in that area, some people were used to herd cattle. Now, whenever they want to bring the cattle to this side for the greeny areas to feed the cattle, they have to take the cattle for 4 kilometers, find a bridge, and come back. That's a massive mistake which we have done. We haven't touched this guy. So we have to showcase the important social as well. Then explain how solving it at the value or innovation. You have to market your innovative ideas. You really have to do that. If you are not doing that, no one would catch you. You have to market the innovation of a project. Okay, example is there. Forget about the example. Then we have some idea, background idea is there. We have understood the problem. We have collected some background knowledge. But how do we put that into the research or methodology? How do we really do that? Again, we are very good at talking. We say we know this, that, and so on. We are still proud of the world best irrigation system in the country. We have the world best irrigation system in the country. We are very proud to say that. Have we done enough? Have we even analyzed that? No. So if you ask me, if I have a problem and if I have done my homework to understand the problem, and then I have understood the background, who are affected from that, my next step would be sketch the problem. Oops. Okay, these are my own sketches. They might not be really clear, but this is one particular problem. Now this is for someone level reservoir. I'm sorry, my own handwriting when I had a time. I use some sketch like notebooks, and I used to sketch. Even now I carry the sketchbook with me, so I just sketch it. Now this problem was brought to me when I was having the survey camp in Samanalawa area. So we took students to do the survey camp in Samanalawa, and everyone was talking about this leak in Samanalawa. It was for ages now. Now we found a solution as well. What was that solution? We found that leak and take that water and introduce another mini hydropower station, which is good. Without simply discharging that water, you are at least using that water to generate a small turbine and get energy back to the system, which is kind of good. So I was thinking that bit ahead, can I try to formulate the power generation with respect to the rainfall in that area? So I wanted to thought about that particular problem. So what I have done is I just sketched the area. So that is my Samanalawa reservoir. I have the power system. Then I thought these are the rain gauges in the area, and can I model it? So I just sketched it. What I have done here is I have given a visual interpretation to my problem. Okay, visual interpretation. Then I have noted down power. Okay, power is a function. You have mathematics, rho eta times rho q g h. That's the power equation. So that's engineering. No one would understand those things. But can I formulate power as a function of rainfall? So it was a very basic idea long time ago. So when we have this sketch, we can openly discuss with our collaborators. Rather than speaking things, you have a sketch and you can table it and you can discuss it. It's very easy. Graphics are very easy to understand. Unlike the text, when you go and if you're asked to evaluate the poster presentation, you don't like to see a chunk of text in the poster. Instead, you like to see a lot of visuals, graphics in it, and to give clear picture of that. So that's what we are doing exactly. Then imagine this was published in a very good journal paper. Then we had another field visit. Okay, these are field visit not because of any reasons. I just like it and I go. So Denevaka catchment. Denevaka catchment is an interesting catchment where we have a mini hydropower station owned by Valuable Power. So I thought of doing the same thing to mini hydropower. So the difference from here to there, we have a reservoir. Now we don't have a reservoir here. It's mini hydro. Just across the river, you have a small dam, and you get water and feed it into the turbine. So we did it, and we got data from Valuable Power, and we sorted it. Now at the same time, there is another mini hydropower in Ratnayake. So Ratnayake is, if you know, it's a conserved area where you don't have a single rain gauge in the catchment. Now I wanted to forecast again the power generation in such a catchment where you don't have rain gauges. At that time, the satellite images, satellite data were not really popular. So we took the challenge and we looked at the surrounding rain gauges. We drew the catchment and we obtained the surrounding rain gauges and we sorted the problem. We developed the AI model to focus, and that was the time 2016, 2015, where we haven't had enhanced AI introduction. Now, if you look at these three sketches, it's very easy for me to read them to you. Just took 2 to 3 minutes for me to read them to you. But to develop that, you probably need 1 day. These are out of several iterations. You draw it, you throw it away, and you redraw it, and so on. So you will take a significant time. You will take a significant time to develop such a sketch. So you need that. Then only you can talk with your collaborators and showcase that to you in an understandable manner. So rather than saying you are developing an AI model to generate the power generation from someone level, go and speak with this such a sketch. People would understand. So now that we have sketched the problem, then I would like to define the constraints and the scope. As I told you with the Ratnayake case, we don't have much data. So we have to define the constraints. What are the limitations what we have? Then what is our scope? Because you can't do everything. You start with a small step, then you are moving ahead. So you have to define the constraints. Sometimes this guy is very important, geographical boundaries. Now, without telling the names of the countries because it's live, so I will tell you one of the difficulties which I faced. We were collaborating with one of the neighboring countries to Sri Lanka, and we worked for a particular catchment. It was a super work, and then we wanted to publish that paper. So we sketched the country map, and then we have showcased the catchment map. So it was a wonderful paper. So we sent it to a journal. Right after a couple of days, we got it back from the editor himself or herself, saying that you can't define this country boundary because we have another neighboring country has issues with this country regarding one boundary, geographical boundary. So you can't define the solid boundary. Remove that country figure and resubmit it. Okay. Look at the difficulties which you are facing. Remove that country. Luckily, Sri Lanka is not facing such thing, but the neighboring countries are facing such things. So the boundaries are well not defined. So they have some arguments. Now, these are human factors. So we had to, we wanted work to be published. So we simply removed that without arguing. We simply removed the country map and we kept the catchment map. Editor accepted that thing. So he sent it to the reviewers. Now it is under review. So if we say that we are not removing that because of the paid peership, probably it won't work at all. So you have to negotiate as well. So list all technical, economic, geographical boundaries. That is very important to a research work. Understand what my skills are. As I told you, we can't do everything. We can't really do everything. So you have to understand what my skills are. Then, if it is not enough, bring the skills. For example, we were working in medical science field, health science field. I don't understand most of the things in medical science. So we bring the necessary skill to the problem. That's what we call the collaboration. And that's also called the teamwork. It's not an easy task. You know that if you look into the audience here, we have somewhere around 30 odd people, where we have different ideas in our mind. They are contrasting, competing, and conflicting. And whenever you want to bring them into a table, into a research problem, it's not an easy task. But yet, you have to do that. You have to accept others' idea and you have to discuss it openly. So the teamwork is very important in research because there are no one-man shows like Supermans in the world. It's a team effort. If you go into Toyota Japan, those who were in Japan, they probably know how many research engineers do they have. thousands of research engineers are working in Toyota. So you call it new versions of Toyota now. I'm not promoting them, but I'm telling you the truth. If you look into that, they had the vehicles like petrol vehicles, diesel vehicles. Then they came with Aqua. Aqua was the Toyota Prius C, compact version of Prius. That's what we call Aqua. It's popular in everywhere. Unlike, in Sri Lanka, we don't like it because it's very low-word and it hits all the places. But it's a fantastic car where it works for 30 kilometers per liter. So again, this is a product of research. Now they are moving into Mira. Mira is like hydrogen type of vehicle. So they have it now. Tesla, the same. So teamwork is very important, and understanding your team and negotiating with them and appreciating them. So it's very important. Then, as I told you, many research work now are multidisciplinary and interdisciplinary. You probably heard yourself when it was a time when you were studying for your A levels. You had Newton's law of gravity, Newton's law of thermodynamics, Newton's law of this and that and so on. How on earth a person to do thermodynamics, mechanics? Could have been a teamwork, probably given under one name. So just like that, most of the problems are now multi or interdisciplinary problems. So you have to acknowledge the assumptions and the limitations. That's very important. We have to acknowledge these things, assumptions and the limitations. If not, we can't do. Why? Because we always need to find alternative ways. When you are in the research track, you will notice that you think that you are doing this, you can't do it because of various other reasons. Sometimes these are out of your control. So you always have to find alternatives as a researcher. Yeah. Okay. Sorry. Yeah. Then I wanted to do a bit of, I have now understood about the background of the problem using newspapers or whatever the generic knowledge. But that's not enough. Remember the hierarchy which we told. Understand the problem, understand it, read the problem and understand it, read the problem and understand it in physical way. So we have done the physical thing now, but we haven't put the technical stuff into there. So we need to go into the scientific databases. Okay, Google Scholar is one approach. You can search the things in Google Scholar. I'm not saying that everything published in Google Scholar is the perfect. You can find thousands of fake things in Google Scholar because anyone can publish anything in this world now. You can define your own journal and you can publish papers, whether it is not indexed or not. But you always try to go to the indexing journals when you are doing the literature review. But again, for generic approaches, you can select Google Scholar and also select the time frame for last 5 years. You can screen the papers which were published for the last 5 years. It doesn't mean that I'm saying something published in 1970s are not important. Okay, so if you look at the climatic trend analysis, we still use Mann-Kendall equation. That is the one of the universal methods to find climatic trends, Mann-Kendall equation, which was published in 1945 or something. We still use that. So, but in order to understand state of the art, we need to go into the last 5 years. So last 5 years, you might pick loads of information about this thing. But yet again, you have the theoretical background, probably in 1960s or even 1800s. Some theories are driven in 1800s or 1700s, still there. Now, if you look at the famous Pythagoras theorem, you probably know the story of that. Before it was named as Pythagoras theorem, someone else in some other countries were using that. Couple of 100 years ago, some people in Persia and so on, they were using that. So so the knowledge was there, and then sometimes you are still using them. So for the research, you can find the state of the art when you search for the last 5 years. Check what is known. You have to check what is known in research. Because someone, you probably have we have the problem understood. Sometimes someone else has sorted that into different area. If that is the case, why not to take? Because it's open access now in the world. You don't want to keep things hide now. Okay, unlike the military stuff, forget about the military stuff. But most of the other things are not like, they are not hidden. So you can even ask for various things. Now, though it was a time that the coding was hidden from most of the people. You don't need coding now. You basically don't need coding now. You don't need to be a computer programmer to code now. You have most of the freely access stuff. If you can read it, that's it. You can apply it. So check what is known. Then understand the approaches. This is important. The methodology is driven in these research publications. So you understand them and you are reading them. Can we apply something similar, or can we apply something advanced to that? Then again, cross-check with my skills. Am I able to complete the task with my skills, or do I need more? And also, we need to cross-check with the resources available. If the resources available is not enough, then you have to rethink your approach and find alternatives. If someone asks me to do Dadroya again now, okay, if someone asks me to do the Dadroya again now, would I use the same Landsat images? No. My answer is no. I would rather go to Sentinel images, which gives me 10-meter resolution. So 30-meter resolution, 10-meter resolution, which is better. And also, I would probably go with drone technologies now. You can fly a drone and you can get the LiDAR images. Simply the morphology of the river. River bathymetry is there. So you just get the river bathymetry and feed it into probably QGIS or ArcGIS, you solve the problem. I can do comprehensive modeling. So look at the things. So back in 2017 or 18, I was using different techniques. So since I have read the information, I can use latest technology to do that. So LiDAR images are very powerful. If you read the interesting stories about the Latin America, they have discovered major cities under the soil layers. 2 to 3 meters of soil layers underneath, you have discovered major cities with extraordinary architecture and so on, and LiDARs. So you can use new technology. But if you don't have the resources, you have to always find an alternative method. So that's why we are cross-checking with our skills and also with the resources. Thank you. Okay, then we did a bit of a literature review. That's a generic literature review. Then we wanted to go into the depth of the technical stuff, which we call the systematic literature review. I'm not focusing on the medical sciences systematic literature review. When you want to do the systematic literature review for medical sciences or health sciences, you have a different way of doing that. You have to register the analysis. You have to register your work with some standards. Then only you can do this. But instead of that, we can go into Scopus databases and so on. You can search the relevant publications and read them again and get skilled with what is known. Okay, So our aim is known. Why? Because we know the problem, we know the gap, that is the gap, and that is obviously the aim which we are trying to sort. What do you think about aim and objectives? Are they the same? In most of the time we think they're the same, aren't they? No, unfortunately no. Objectives are the specific steps you will take to achieve your aim. So objectives are the steps which you take to achieve your aim. So you have to define the objectives properly. Why? Because your objectives are going to drive you into the methodology section. And importantly, aim is what of the research, and objectives are the how of the research. So we not us, but almost all in this world, we misunderstood these two, aim and objectives. Even if you find research dissertation which are published, you just have aim or objectives, aim of the research or objectives of the research. So you usually should have both of them because they are different. And objectives should be started with an action verb to determine, to analyze. These are action verbs, and which are usually logical and coherent. And they should be feasible. Your objectives should be feasible. When you are facing your defense, say the initial defense as a candidate for a higher degree, you have to present your proposal. When you present your proposal, your examiners will be asking, what is your aim and what are your objectives? Then they will surely ask, are they feasible? Can you achieve these things within the 3 years or 4 years time when you're doing a PhD? I'm just recalling the PhD. If not, when you're doing a master's, your candidature is under these criteria. Can you achieve them? Because you are spending 2 to 3 years or maybe 4 years of your life for a research degree, and if you're not achieving them at the end of the timeline, you're losing the game. So you have to define the objectives which are feasible. Then realistic, considering the local conditions, they should be realistic, and operational terms can be measured. You should have to measure the objectives. How you have achieved these objectives? What is the amount or the percentage of achievement? Because when you are doing a research degree, time to time you have progression and progressive meetings. You have to showcase that I have achieved 80% of this objective, and so on. And also, when you are doing a higher degree, objectives are the usual categories for your journal papers and chapters. Just like that, in your research, when you're doing it for a consultant project or a journal paper, like a manuscript, you have to clearly define, even though you don't write them in your research paper like objectives, but you have to define them. Yep. Then we have to develop the methodology. This is another important thing. So you have understood your aim and objectives, so you know what to do. And also you have done a clear literature review, and you know what are the steps that some others have done. So can I use the same thing, or can I use some extended version, or can I put my skill to develop a novel idea? So if you look at the first case study which I have presented to Dadroya, I'm not the first one to do that. I believe loads of people in this world have done that. Meandering analysis with time using Landsets. I believe more than Landsets at that time, people might have used some other techniques as well. So I followed their methodology. I basically followed their methodology to develop a research problem to the local or localized context. But the second work which I have presented, it was a novel work. It was one to the first in the world. So we brought the creativity to that. See the difference. That's why I presented these two. So we brought the creativity to that as well. We read the available papers. At the same time, we thought ahead of them, and we thought, why can't we do that? Shall we try it? So developing a methodology for that is very important. So I'm revisiting my skills. Technical support. So I have to develop a methodology which is executable. So we have to develop a methodology which we can do with the timeline. Now, for example, when we are working as a team, we define a timeline like 3 months. We'll finish this work and we'll publish a paper. We'll work on 3 to 4 months of this particular work, and then we get sorted the things, and at the same time we'll work on the writing of the paper. So that's how we are developing the thing. So the methodology should be feasible and executable one. Break down the methodology into subsections. We can't keep everything in our mind. Just like that, we can't do everything in a holistic manner. So you have to subdivide into the various sections and feed into the system. So you always have to have alternative ways. That's very important. Now, there was a funny excuse when we were doing our bachelor's studies and so on. We used to say that my computer was cracked, my computer was broken, and I don't have this data file now, and so on. We in fact use those things as an excuse. You probably heard that when we said that your supervisors and said that, why can't you keep those in some other places and so on. We said we forgot to do that. So you can't find excuses like that now. So you always have to have alternative ways. If you are a researcher, you have to have alternatives. You need to find thousands of ways of achieving the things, achieving the aim. So that is very important. And you never say no. Then execute the methodology with a clear focus. This one is very important. When you do the research, you have to disseminate the outcome. If not, no one knows. If not, no one knows. I would take one example. If you look into the sediment transport, an empirical formula which we are using now is Meyer-Peter-Muller equation. Okay, sediment transportation is one of the most complex problems in the world, which we don't have a generic solution now. Even now, we don't have. So we have a formula which is an empirical formula called Meyer-Peter-Muller. 3 scientists' names, Meyer-Peter-Muller equation from different countries, I think. I don't know how they engage in the research in 1800s, 1700s, and so on. Somehow they have done. Now, if you go into the Japanese history, you will find out that the same equation was used in Japanese academics 300 years ago, which was developed by Meyer-Peter-Muller. Even 300 years ago, Japanese scientists used the same formula, exactly the same formula, empirical equation, with the same numbers. Now, it's very interesting, isn't it? But unfortunately, due to the language barrier, which you can probably say, they haven't published that. They haven't sent it to the academic community. So we still call that is Meyer-Peter-Muller equation. So just like that, when you develop something, you need to disseminate it publicly. So if possible, openly. Now, as I talked with Tarindu, and everything is open source now. You're not hiding anything. You have to give everything to the world. And when you publish a research paper, you will notice that you have to write that data availability statement. But you always have some terms in that. You can always say that data is available from the corresponding author upon a reasonable request only for research activities, not for commercial activities. When it is commercial, you have some other stuff, because when you're working, for example, if you have done a research paper, suppose he has done a wonderful research paper, he can't sell it because it's not his own research work, it's this institution's research work. So you're bounded with the institution, just like that the universities and so on. You have these teams in most of the universities now. You have a marketing team in the universities, which you are missing in Sri Lanka. You have a promotional team, development team for research, legal team looking at the legal aspects. So you have to bring an agreement and sell it to the commercial, and which is happening in the world. Okay. Google Scholar page, ResearchGate, LinkedIn, and so on are kind of good areas to give some publicity to your work. See, you are disseminating that. Which, like, we have done this. Why not to use that? Again, it's a business model. See, you're promoting the work. You're promoting the work and asking people to do. If you're not telling that, no one knows it. You are the best person to sell it. When you have done it, you are the best person to sell it. Okay. So what is needed? We need curiosity. We need the attitude and the curiosity to do research, to desire to explore and understand things deeply. We need that curiosity. So unlike we are book driven, reading everything, cramming everything, and writing exams and getting A's in examinations, it is not the best deal. Yesterday, when I was talking, one kid a kid came to me and he was asking, I'm just having a second lower, can I do research? So he was in the idea that he's not having a first class degree or a second upper. So he was having a 2.7 something GPA. Now, he's from mechatronics engineering, and I told him a particular name, who got second lower degree in the same area, mechatronics, and I told his name. Do you know this guy? Yes, I know him because he is a couple of years senior to me, and he has done some demonstration for us as well. So he got a second lower, and most probably he's getting his PhD call within another week or two, because I know that, and it's almost finalized. So this guy has second lower degree and moving into PhD without a master's. And there was a time we are saying that if you have a first class degree, you can jump into direct PhDs and so on, which I really don't like. I like master's PhD pathway. That's my personal belief, but forget about that. So, but the world is moving in a different direction. So, when you have a second upper or first class degree, you can directly move into the PhD. That was the scenario. So second lowers, yes, you can do it, but you have to do some masters and catch up some stuff and get to the PhD. But it has been changed now. If you have several good journal papers under your name, you can jump into that. I'll tell you another example. So we were having interview. We had a research problem to solve. That's another one of my ideas because of the newspapers. Setu Samudram project. You probably heard about Setu Samudram, and it's in the debate for a number of years. We are talking about it and opposing it, opposed by not the central government of India, by the county governments in the India, and because of various reasons and so on. But have we done a scientific analysis to that? No one has done a scientific analysis to that. So I wanted to do that, but unfortunately, I didn't have funding at that time. I still wanted to do that. I didn't have funding. I mean, to recruit a student to do the PhD on that topic. So if you want to recruit a PhD student in the Ireland or the UK, you should have at least €150,000. That's the minimum which you're talking about. So I didn't have that money at that time. So I talked with one of my friends. I told you Komali Kantamanini is originally from India, but she's in the UK for almost 20 to 25 years, and she's the co-director for United Nations Spider Program. I just told her that, see, Komali, I have this particular problem and I'm interested to solve. She simply said, Upaka, wonderful idea. I'll try to talk to my university and get a grant, and let's do it. So we got the grant. See the alternatives, okay? So I couldn't get it for myself. I'm not worried, because even though I'm not the primary supervisor, I don't worry about it because the work is done anyhow. Then we were interviewing. We got 290 odd applications for that, just for one PhD question. And we sorted everything, and finally we interviewed 4 guys. I don't want to tell the names of the institution. 2 from Sri Lanka, and 1 from a very good state university engineering faculty. Another guy from a private engineering faculty in Sri Lanka, and another 2 from India, 1 from IIT. When you tell IIT, you know the quality. They are top hundreds in most of the cases in the universities. And we had another guy from NIT. Am I missing the time? Oh, yeah, a bit. I'm sorry. I'll finish it soon. When we interviewed, we had myself, the Homily, and we had another director for United Nations. He's from Vienna. And we had another senior professor from the University of Central Lancashire, and so on. So we went for the person who had a second-class degree from Sri Lanka, again from a private institution, ahead of the first-class holder from the state university, one of the best universities in the country for engineering. What was the reason? The attitudes. Basically, it was not me, because I was probably personally impacted because I'm a Sri Lankan. But the United Nations director, he told that this particular first-class holder is probably, he knows everything. He doesn't need a PhD. So the way that his attitudes in the interview. So we went for the second-class holder from the private university in Sri Lanka, and surprisingly, it is just 8 months now. He has completed a full journal paper. Very good attitude, and he's from Badalkumar area. Not really good in English, but super class guy who is eager to learn new things and so on. So curiosity and attitudes are very important when you are doing a research work. And open-minded people, so you are willing to accept loads of information. I'm not saying that you have to buy things. Instead of buying things, you can listen to them. If it is needed, take it. Then time management is very important, because we are not doing time management. Sometimes when you are not doing time management, someone else will do the job. That's in the history. Some other people will go again, it's a race. Whether we like it or not, it's a race. And critical thinking, it's very important. So we need these things. Okay, finally, again the attitude. So I'm almost finishing. Now, what I wanted to do is, I have given the initial diagram of starting a research. Understand the problem and bring it to the research table. I would like to see at least 10 of you to develop a problem which you are seeing daily in the research. Sketch it, discuss it with your friends and so on, peers, and do it. So that is my intention. Probably you can get some support from the institution. Like, you don't need financial. Definitely, you don't need finance to do the research. Just get the available things and develop some research ideas. If you are doing so, I'm very happy to guide you. That's it, guys. So I'm sorry I have probably taken 15 minutes more than time. So if you want to contact me, you have the contact details of mine. So yeah, any questions or any comments, I'm happy to answer. If I can, as I told you, I'm not an expert. Anything? All good? Are we happy? No, I'm not. I'm not a lecturer. I'm just. I think I'm a friend. That this is again one important thing which you are missing. Um, when you're teaching in my home university, you get loads of questions. You shouldn't be scared to ask questions, specifically when you think that my question is a stupid thing. That stupid thing is the world best thing, and that has already showcased. Think about the story of Thomas Alva Edison, who was kind of kicked off from the school. So he was not performing and he failed 1,000 times. Okay, forget about the number. It's just to motivate you. It's definitely not 1,000 times. But he failed 1,000 times and then he succeeded 1,001st time. So still I'm doing mistakes. I'm doing errors. So you shouldn't be scared to speak. And if you ask from the neighboring countries like I'm appreciating them, China, Japan, and so on, they're speaking a lot. Even though they don't know the language, they speak a lot. When I visited Vietnam, this was really interesting. We used to carry business cards with us. Japanese people have this business card concept. You carry several business cards and share it. When I visited China, uh, Vietnam last year for a conference, I was chairing the conference, and several students came to me and they told, "This is my business card." I was wondering, they was just showcasing their phone. It's a QR code. It's simply a QR code. Zero cost, green. You just have to scan it. That's it, and it's free. You can do it. We can do it. We haven't thought about it. Carry your CV with a QR code. That's it. You just scan it. See, instead of the printed card, just scan it. Simple as it is. So, any questions or comments? I'm happy. See, most of the journal have their own format. Data availability statements are there. When you try to submit a paper, you have that is written. It's a legal document. It's a legal document. You tick that box. See, you can copy and paste it. Data availability statement is a legal document, so you can use that. So that's there. But again, you have the right for your data. If it is your primary data, you have the right. If you want to share it, you can. If not, you can't. Was it a journal? I'm not too sure about the conference though, but usually if you go to the index journals, this is why I said index journals, usually they have data availability statement, ethical concern, and so on. Now, you probably have seen these. Most, sometimes even the conference papers or some non-index journals, you have faces, human faces in the journal papers. You can't do that. In index journals, you can't do that. They will right away ask you to the ethical concern, and they'll ask you to blindfold the ISIS to give the anonymous or the identity. So just like that, the data availability statement is usually available in index journals. When you submit it, you just tick the box, you copy it and paste it. Yeah. Yep. Actually, it's a very nice part to consider. So I'd like to ask a very underlying question. Is regarding so what this let us know about what are the important attributes that would really select the research problem or say for such proposal. What are the attributes? Okay. Now, I told you time to time we have catchy words. We had this sustainability for some time, Millennium Development Goals, and so on. Now, Millennium Development Goals, now we are heading to United Nations Sustainable Development Goals, 17 goals. So 17 is the integration of the rest of the 16, I think. If you read United Nations Sustainable Development Goals, and if you can think critically with the country situation, you can develop millions of research problems because we are trying to. It is one of the most important cases. You are trying to achieve the sustainability. Okay, it is a catchy word. Time to time you get this circular economy, green technologies and so on. But again, if you're looking for a research problem, I always take the discussion part of the research paper linked with the United Nations Sustainable Development Goals. Why? Because we are targeting the audience. In order to target the audience, we need to understand what is happening in the world. So if you ask me the correct attributes and so on, to identify the research problem, I usually say just read the Sustainable Development Goals. For example, SDG 9 for climate action. Is that 9? 6? I can't remember. So you have the numbers. So if you read the climate action, you will notice that we are facing massive issues to the country in Sri Lanka for climate because IPCC 6 report, which is going to expire soon, they have clearly said that Sri Lanka is, I think, third most affected country in the world from climate change. We think that when it is climate change, we simply think that, okay, we have more disasters. Now, did you know that we can't call natural disasters anymore in the world? United Nations agreed to tell it it's man-made disasters. You can't call it any more natural disasters in scientific publications because United Nations agreed to tell that. Just like, we had a time called disabled people. You can't call it disabled people now. It's differently able people. Just like that, you can't call natural disasters. It's man-made disasters because we are responsible for every disaster in this world. Now, yesterday was the shortest time in the world for a day, isn't it? So, remember when I read that article, I noted that. I didn't know that. When we started, we had only 19 hours for a day. So it changed. Now, I'm taking the same example into Three Georges Dam. That's the biggest reservoir in the world and which generates more than what Sri Lanka needs as the electricity. It's wonderful engineering work, isn't it? But again, it has impacted the Earth rotation by milliseconds. So we created these problems. So if you look at the attributes, I always go for the United Sustainable Development Goals and see and understand with the environment. You definitely can get 1,000. We are not, unfortunately, we are not hitting the climate action to agriculture in Sri Lanka. We are so-called saying that we are the best, or the Ceylon tea is the best. We're just saying it, but we are not forecasting for the future. What is going to happen with the climate change? What are we going to do? How we are going to compete with the market? Back in 20 years ago, Kenya was not there in the business for tea. Now they are one of the biggest markets in the world. We haven't played. And in education, we haven't played. Even yesterday, I was telling this story. I'm sure you probably know AIT Thailand, Asian Institute of Technology Thailand. Did you know that it was proposed to establish in Sri Lanka, and we opposed? We strongly opposed without knowing the fact. AIT was never meant to have bachelor's programs. It was to do masters and PhDs. Now, AIT Thailand attracts loads of foreign students. At the same time, most of the researchers from Japan and around the area, they are coming for sabbaticals in AIT. Look at the knowledge transfer. We miss golden opportunities, but we are still not thinking about the futuristic education in the country correctly. So again, that's a research problem. Someone has to sort those things. Yeah. Any other comments? I hope I answered your question. Yeah. Any other questions or comments? Okay, if you want me, if you want to connect me, I have my personal email. You can connect me at any time, because I don't put my university email into the mobile phone, but I have my personal email to my phone, so you can contact me. Or if you need my WhatsApp, I can give my number as well. Yeah.
What an insightful speech. Please give a big round of applause to the lecturer.
Thank you so much.
So